Your best in-sample parameter can be the wrong thing to trust. A bright peak says where one historical sample looked best. It does not tell you whether the nearby shape survives new data. Do not ask, "Did I find a winner?" Ask, when the same coordinates move out of sample, do their relationships hold together? Think of a parameter sweep as a landscape, not a trophy shelf. One axis changes an entry setting. The other changes an exit setting. Each cell holds net P and L for that combination. One tall in-sample cell may be a narrow accident. Ask whether the surrounding pattern at identical coordinates keeps recognizable structure out of sample. Freeze one coordinate, the same entry scale and exit scale. Replay that coordinate once, then slice its net P and L into in-sample and out-of-sample windows. Do not slide to the nearest green cell. Do not let an out-of-sample peak choose a new coordinate. Paired values must come from one address on both surfaces. That is the comparison the source computes. Place the surfaces side by side. Both use entry scale horizontally, exit scale vertically, and net P and L in US dollars on the same color and height scale. The 8 values on screen are hypothetical teaching data, not a candidate outcome. Shared scales matter. Independent color stretching can make a weak out-of-sample shape look stronger. Here is a hypothetical 3x3 teaching table. Read the 8 admitted coordinates row by row. In-sample net P and L is -600, -300, -100, then 100, 300, 500, and $1,000. The same 8 addresses out of sample are 100, -200, 300, -$200. The 9th coordinate has no out-of-sample value. It stays hatched and excluded. No dot, rank, or coefficient. This is not a candidate result. Pearson now uses those 8 hypothetical pairs. It asks a magnitude question. When in-sample net P and L moves upward, does out-of-sample net P and L tend to move upward in a roughly straight pattern? The computed Pearson coefficient here is 0.434. It clears this configuration's strict greater than 0.3 Pearson gate. That is illustrative arithmetic, not a causal explanation, profit forecast, or current candidate outcome. Spearman ranks those same 8 hypothetical pairs and sets exact dollar distance aside. Its coefficient here is 0.19. It fails the strict greater than 0.3 Spearman gate because the ordering twists. Some middling in-sample coordinates land low out of sample, while lower ones jump above them. A scatter can retain some linear magnitude alignment, while ranks fail to stay consistently ordered. Pearson and Spearman are not duplicate victory stamps. Now apply the configured 2-gate corridor to this hypothetical table. Pearson 0.453 clears its local strict greater than 0.3 rule. Spearman 0.19 does not, so the corridor fails. That is a teaching result for these disclosed numbers, not a field pass or failure. The thresholds are operator policy, not a p-value, confidence interval, universal truth, or proof that any strategy is sound. Before trusting a pattern, ask what surface was drawn. The source records full permutation or sampled procedure. With coverage, sampled does not mean useless. It means sampled. Put that on screen. The same caution applies to candidate scope. A tidy illustration is evidence about declared coordinates, not a universal fact about every rule set. One scope boundary remains. Some candidates have parameterized entries and exits, so their surface is entry by exit. Others can be labeled exits only when entry is not parameterized. That label is not a universal fallback. The source warns an exits-only candidate can still be unable to run when required exit behavior is missing. Read the scope as candidate-specific, then verify later under authorization. The misuse list is short. Do not pair nearby coordinates. Fill a missing cell with a guess. Pick a prettier out-of-sample point or hide a sampled grid. Do not use one gate to erase the rest of your research. Each shortcut makes the picture cleaner. By changing the question, the honest picture keeps awkward evidence visible. What would a clean correlation gate give you? Bounded evidence that this candidate's paired surface showed specified agreement across admitted in-sample and out-of-sample coordinates. Useful, but limited. It would not prove future profitability, solve selection bias, establish causality, guarantee execution after costs, or make sampled coverage exhaustive. Keep the coordinate thread intact, the evidence state visible, and let the next test earn its claim.